Hello everyone, I'm Aditi Kinkhabwala from New LG Institute of Engineering and Technology. Let us start with the Unit 2 and the topic about stacks. Now students, in this chapter, specifically in this topic, we are going to see the different definitions and concept of stack and what are the operations which we can perform on stack. So now let us start with the basic definition of stack. Now stack is an important data structure which stores its element in an ordered manner. Now students, we know data structure. What is data structure? It is a way of organizing data. Okay, so we structure data in such a way that we can do efficient things with it, right? So one of the structure in which we can organize our data is stack. Now, stack stores its element in an ordered manner. For example, if you can see here, this is a stack of books, or we can say a pile of plates, or a stack of CDs or DVDs. So here, if you observe, one common thing is elements are arranged at top of each other. Now, stack is called a linear data structure. That is, the elements are arranged one by one, that is linearly, and it has one principle, which is that elements in stack can be added and removed only from one end. Okay, so the structure is something like this. Here we can add or delete elements one by one, but it can be done only from one end, right? So either we can delete or we can add it, but one condition is there, that it has to be from one end. And that's why it is called last in, first out data structure. Why? Because if you see here, as one is inserted, so it can be inserted from top, then two is inserted, 3, 4, 5, and so on. So as you can see here, the elements, now when we want to remove, so removing element is on also from that end only. So when we want to remove, we can only remove the element which is inserted last. And that's why we say that it follows last in, first out way, right? So for example, if this is a stack and if I say insert one, so one will be inserted, two will be inserted, 3 will be inserted, right? Now, if I want to remove the last element which is inserted, that has to be removed first, right? So this is how we say that a stack is following LIFO order, that is last in, first out. Students, where do we require stack in the field of computer science? Now, you must have already gone through the topic of functions in your PPS subject. So basically, if you remember in recursion, what is recursion? It is function calling itself, right? So whenever, or if we say whenever we do function calls, right? So in main, we call some functions. So consider an example here where we are executing a function A, right? Now, while execution of function A, if function A in turn calls some another function, which is B, so what will happen? Function A is already working and it has called some function B. So function B will also be there on the stack because it is keeping the track of how many function calls are being made, right? Now, if B in turn calls another function D, right? So B in turn calls another function C and C again calls D. So what is happening at this particular situation is A has called B, B has called C, C has called D, right? So each and every function is currently open. Now what will happen? Function will start getting solved one by one. So now there are at the current moment 4 active functions. So in order to keep track of the returning point, that how these functions return values of these all active functions, we require a special structure and this is called a stack, right? We will use a stack in order to maintain an active function directory. So whenever function calls another function, calling function is pushed onto the top of the stack. As you can see, function A, now A has called B, so it is being pushed on the stack. then C is pushed, and then D is pushed. Now, once D is solved, right? So it will return the answer to C. If C is solved, it will return answer to A, it to B, and if B is solved, it will return answer to A, right? So as soon as function starts getting executed, they will get removed from the top of the stack and they will execute, such as function D is executed, then C, then B, and then at last A is also executed. So it is mainly used in function calling. Also, if you see the practical example, you must have seen during your web search, right? If you search anything on web and if you click on the link, it will traverse you to some another page. If you click some other link, it will take you to some another page, and so on. Now, when you click on the back button on your web browser, what happens? The last page which was opened, right? It was the first to get closed, right? Because when you click on back, the last page which you opened is the first one to get closed, right? There are very important applications, real time application, as well as it is very useful in memory management, function calling, and other concepts of computer science as well. Now, how stacks are represented? Now, students, you have studied in arrays that it is basically stack is an abstract data type, right? So it is a conceptual concept. And in order to implement this, we can use arrays as well as linked list, right? Now, in computer memory, one of the way to store this stack, how to represent this stack, it is in form of a linear array. So this stack is nothing but a group of memory locations, which you can say as arrays. So each stack has a variable called top associated with it. And this top will help us to identify what is the last element which is there on the stack, right? So this top is used to store the address of the topmost element of the stack, and elements will get added and deleted from the top, right? So the array representation is array indexing starts from 0. So it starts from 0 to n minus 1, right? And as per this diagram, as you can see, currently the last filled location is at top 4. So if you want to insert an element, you have to see the topmost element, and then the next, at the next spacing we can insert also. And if you want to delete, so it can this wherever the top is currently pointing, that element could be popped, that is deleted also, right? So this top is a pointer which maintains this addition and deletion onto the stack. Now, students, let us see what are the operations on stack. So there are many operations which we can perform on stack. They are push operation. So this push operation is for insertion. If we want to insert an element on the linked list, we use insertion. Pop is for deletion. If we want to delete an element from the stack, it is deletion. Peep is finding. If we want to find any element in an array, it is peep operation. And change operation, it is in order to change any element inside the stack, we use the change operation. Now, students, if you consider this situation, right? So if you want to insert, you can insert it from the one and only. So we are inserting 1. Then when we insert 2, 3, and 4, right? So this is how we have to insert it. Then we can remove element one by one. So the last inserted is the first one to be deleted. Now in this stack, whenever we want to find any element, that is, for example, if we want to find out the third element from the top, and if this is the top, the third element would be 1, 2, and 3. So we can find what is there on this third element, that is on the ith index, and this I could be anything, 1, 2, 3, anything. And on this ith index, if we want to change any value, right, instead of 2, I want to make it 20. This is also possible using change operation, right? So we are going to see them in detail, and algorithms of all 4 also that we are going to see. One thing, students, which we need to remember is that while inserting and deleting element, every stack has a fixed size, right? So if a stack is having a fixed size, we need to check before inserting. If we are inserting, for example, the stack size is 4 and we are trying to insert something at 5th position, but the stack is already full, right? So we, before inserting, we need to check one condition, that is full. That is the stack full. In that scenario, what will happen? It would be a situation of overflow, right? And before deleting, we have to check for one more condition, and this would be, so we have to check for the empty condition, because students, if the stack is empty, we cannot delete anything, right? So it is again an error condition which is known as underflow. So these are the two conditions which we will check every time for different operations. In some operations we require to check full, and in some operations we require to check is the stack empty, right? So we need to check that before actually doing the procedure. One more operation is there, which is peek, P-E-E-K, and this returns the topmost element where the top pointer is pointing. This returns the topmost element from the stack. Now students, let us see what is the push operation on the stack. Now push operation is for insertion. Okay, so we need to insert an element on the stack. So this procedure inserts element X. So this X could be anything, 5, 10, 15, 20. This, it will insert on the top of the stack, which is represented by vector S. Stack is represented by an S containing n elements. So there would be n elements. So size of the stack is n. Now from this diagram, let's assume that it is 4. So this is the size of the stack. So it can have maximum 4 elements. And what will top denote? Top will denote the topmost element. Okay, so this is, if you see here, if this is top, currently if the stack is empty, top is 0. Then if stack is not empty, it will have the counters like this. Now students, in order to check push operation, so this is the algorithm for push. What we require a S, right? We require a stack in which we want to push. We also require the position of top, where it is currently located. So top could be at any of this position, right? And we require X, which is the value which we want to insert. So before inserting, students, we need to check whether the stack is overflowing or not, right? So whether stack overflow condition is true or not. So currently consider a situation where stack is empty. In that scenario, what is top? So currently no element is there, so top is 0. Our n is 4. So is 0 greater than equal to 4? No. So stack is not overflowing, right? So stack overflow condition is wrong. That means we can now insert an element into the stack. So what is the next point? We need to increment top. So top is 0. So now it is top plus 1. So here the top would be pointing at 1 now. And now we need to insert element at S of top. What is S of top? S of 1. So stack of 1, this is what S of 1. Stack we are considering as an array, right? So stack of 1. Now here we will have X. So what is X? 5, right? So here 5 is inserted. Now again, if we want to insert one more element, again overflow condition is checked. Now this time top is at 1, but again 1 is not greater than equal to 4. So we can increment top. So our top is this at 2, and S of 2 would be, for example, 15. So S of 2 would be 15. Again repeating it the third time. Now this time currently top is at 2. Again it greater than equal to 4. No. Again we will increment top, and now S of top is at 3. So S of 3 will have a value which we decide, that is, for example, it is 20 now. So now S of 3 would be having 20. Again, let's see. So now this time top is 3. 3 greater than equal to 4? No. So top will increment. We can give any value, that is X, to the top, and we can push it. Now when we try to insert it one more time, see students, here top is 4. Okay, so top is 4 and size is also 4. So 4 equal to 4 condition became true, and now it will give us the message stack overflow. And now we cannot push any new value any further because the stack is now full. So whenever the stack increases or is equal to the top counter, we cannot insert in stack anymore. So this is how we are required to do push operation. Now let us see the pop operation. Now students, if I copy the same content here, 25, right? 25, 20, 15 and 5. So where is this is the stack. The current topmost position is this. So what is the algorithm for pop? It takes two things, S and top. We require top pointer and we require stack also. So this function removes, that is, deletes the top element from the stack, which is represented by a vector S, and it returns this element. So top is a pointer to the top of the stack. Here we need to check underflow condition, because if top is equal to 0, in a scenario when this stack is empty, there is no element inside the stack, where would top be? Top would be at 0, and at that particular moment, it would be a stack underflow error, right? Now, currently in our scenario, stack is full, okay? So yes, it can delete the element. Can we decide which element we need to delete? No, because stack will always delete element which is last in. So element which is last inserted is the one which is deleted, right? So that's why we don't require any X over here. User will not be able to delete whatever the user wants. It will be only last in, first out manner. So whatever was inserted last will be the first to get deleted. So now we need to decrement pointer. So the pointer is decremented and we need to return this value. So how can we return the value? S of top plus 1. So what is the former top element? 25. Current top element is, so current top is at 3 plus 1. So S of 3 plus 1 is what? S of 4, and S of 4 is what? 25. This we have to return, right? So 25 is element which is now popped because top is now been decremented, and now the highest position is at top is equal to 3. So this is how we need to perform deletion operation on the stack.